Before the equations, we learn the language of the states. Tpxij, mu x plus tij, the transition matrix Px of t, and the intensity matrix Q at age x plus t. What does every symbol mean, and why do they multiply? At each time t, the random variable y of t says which of the four rooms the life occupies: healthy, rehab, long-term care, or dead. The Markov idea is that once we know the current state, the model forgets the path used to get there. Tpxij is the probability of finishing in state j after duration t, given that we start in state I at age x. T is the duration, x is the starting age, I is the start state, and j is the end state. The official one-year probability we need later is 1p81.0. Start at age 80. Start in state 1, wait 1 year, and ask whether we are in state 0. The first index is the row, where we start. The second index is the column, where we finish. Mu xij is a local instantaneous rate, not a probability. For a tiny interval h, the probability of jumping from I to j is about h times mu. On this graph, mu 80 plus t10 is the rate from rehab into healthy. A transition can only happen to the mass already at its source. Mass entering state 0 in dt is Tp81.1 times mu 80 plus T10 times dt. In general, flow from k to j during dt is the mass in k times the intensity from k to j times dt. Put every transition probability into one matrix. Rows are starting states, columns are ending states. The state 1 row is the whole future distribution given that we start in rehab. That row sums to 1. The intensity matrix Q has off-diagonal entries equal to the transition intensities. Each diagonal is minus the total rate out of that state. Every row of Q sums to 0. Kolmogorov forward is ordinary matrix multiplication. The destination state picks a column of Q. For the derivative of Tp81.0, multiply the state vector by column 0. That gives inflow from rehab minus outflow from healthy, Tp81.1 times mu10 minus Tp81.0 times mu01 plus mu03. To reach destination j at age x plus t plus r, add the probabilities of passing through each middle room k. That sum is Chapman-Kolmogorov. In matrix form, p of t plus r equals p of t times p at age x plus t over duration r. Over a tiny interval h, most people stay put, which is the identity matrix. A trickle of size h times mu leaves through the pipes, which is HQ. The new population is the current population plus h times the net flow. That is Euler in matrix form. P of t plus h is about P of t times I plus HQ. The chain is, intensities give local flow rates, those rates give the Kolmogorov derivatives, and the derivatives give the transition probabilities. Scene 1 can now derive the ALTAM equations without an unexplained symbol. The cohort starts in State 1 rehab. As time runs, people disperse across the 4 rooms. TP811 is the fraction still in rehab. TP810 is the fraction now healthy. The conservation question is, what controls how fast healthy fills? Inflow to healthy is the rehab mass times mu10. Outflow is the healthy mass times mu01 plus mu03. The derivative of TP810 is inflow minus outflow. The initial condition is 0, because nobody starts healthy. At time 0, the rehab probability is 1 and the healthy probability is 0. So the initial velocity is 1 times 0.0800, which is plus 0.0800. That is the first Euler slope. For rehab, inflow is the healthy mass times mu01. Outflow is the rehab mass times mu10 plus mu12 plus mu13. The initial condition is 1 because the whole cohort starts in State 1. Because the rates change with age, we slice time into steps of 1/3 of a year. The first tangent slope is 0.0800. Times h equals 1/3. The rise is 0.02667. That is the first Euler landing. At t equals 1/3, we recalculate the slope. 0.94167 times 0.07667 minus 0.02667 times 0.12833, which is 0.06879. The path tilts down as the rates age. The last slope, at t equals 2/3, is 0.05878. Add 1/3 of that to 0.04960. Part B is 1p8010, approximately 0.06919. Part CI is the fee EPV. Discounted expected years healthy are 5.5793. Discounted expected years in rehab are 1.3813. Add those to 6.9606 expected active years, times $8,000 a year. The official fee EPV is about $55,685. The 40,000 level 2 benefit splits into a 30,000 lifetime base and a 10,000 deferred step-up at age 85. At age 85, 53.88% are healthy, 17.33% are in rehab, and 6.96% are already in level 2. Those three branches sum to 0.59706 years. Drag that age 85 block back 5 years and shrink it by v to the fifth, which is 1.05 to the minus 5, about 0.7835. 10,000 times that discount times 0.59706 is 4,678. The base level 2 EPV is 30,000 times A.8002, which is 18,327. Add the deferred 4,678. Part C2 is about 23,005.